Limits, continuity, and differentiability, the three pillars of calculus. From JEE Main Unit 7. What is a limit? Imagine a function with a hole at x equals 2. The function is not defined at x equals to itself. But watch what happens as x approaches to from both sides. From the left, the dot moves closer and closer to the value 2. From the right, same thing, it approaches 2. The limit is the value the function approaches, even if the function never actually reaches it. Here, limit as x approaches to of f of x equals 2. The formal definition, limit of f of x as x approaches r equals L means, as x gets arbitrarily close to a, f of x gets arbitrarily close to L. In epsilon delta language, for every epsilon greater than 0, there exists a delta such that when x is within delta of a, f of x is within epsilon of L. Here are the standard limits you must memorize for G. Sin x over x approaches 1, tan x over x approaches 1, e to the x minus 1 over x approaches 1, ln of 1 plus x over x approaches 1, and the most famous, 1 plus 1 over x, all raised to x, approaches e. Left hand and right hand limits. The left hand limit is the value f of x approaches as x comes from the left. The right hand limit is from the right. Watch, from the left, the dot approaches the value 2. But from the right, it approaches 3. Since LHL is not equal to RHL, the limit does not exist at this point. Critical rule, the limit exists if and only if the left-hand limit equals the right-hand limit. Algebra of limits. If both limits exist individually, you can split the limit across addition, subtraction, multiplication, and division provided the denominator limit isn't 0. You can also pull constants out and raise limits to powers. But what about indeterminate forms like 0 over 0 or infinity over infinity? Use these methods, factorization, and cancel common factors, rationalization with conjugates, standard limit formulas, or L'Hopital's rule, differentiate numerator and denominator separately. Continuity. A function is continuous at x equals r if three conditions are met. First, f of a must be defined, no hole at the point. Second, the limit must exist, LHL equals RHL. Third and most important, the limit must equal the function value. Visually, a continuous function is one you can draw without lifting your pen from the paper. Watch the red dot trace the curve smoothly, no jumps, no breaks, no holes. That's continuity. Three types of discontinuity. First, removable discontinuity, there's a hole in the graph. The limit exists, but either the function isn't defined there, or f of a doesn't equal the limit. You can fix it by redefining f at a. Second, jump discontinuity, the left and right limits exist but are not equal. The function jumps from one value to another. Step functions and signum have jump discontinuities. Third, infinite discontinuity, the function shoots to infinity near the point, like 1 over x at x equals 0. Differentiability. The derivative of f at a equals the limit of f of a plus h minus f of a, divided by h, as h approaches 0. Geometrically, this is the slope of the tangent line at x equals a. Watch this beautiful animation, the orange secant line connects two points on the curve. As the second point slides closer and closer to the fixed red point, the secant rotates and becomes the tangent shown in green. That limiting slope is the derivative. For differentiability, the left-hand derivative must equal the right-hand derivative. The most important relationship in calculus, differentiable implies continuous. If a function has a derivative at a point, it must be continuous there. But the converse is false. Continuous does not imply differentiable. The classic counterexample, modulus x. It's continuous everywhere, no breaks. But at x equals 0, there's a sharp corner. The left tangent has slope minus 1, the right tangent has slope plus 1. Since left-hand derivative does not equal right-hand derivative, it's not differentiable at 0. Remember the hierarchy, differentiable is the strongest, then continuous, then merely having a limit is the weakest. Key exam tips. Limit exists if and only if left-hand limit equals right-hand limit. For continuity, the limit must also equal f of a. Differentiable always implies continuous, but not the other way around. To check differentiability, verify left-hand derivative equals right-hand derivative. Know the discontinuities of floor function, signum, and modulus by heart. All polynomials are continuous and differentiable everywhere, free marks. For 0 by 0 indeterminate forms, try factoring, rationalizing, or L'Hopital's rule. If you found this helpful, like and subscribe for more JEE and board exam solutions at MAGPIEHUB.